Hi, my name is Leandro Facchinetti and let's write some code together, shall we? What we have on the menu today is a new project. I am starting a new project. It is going to be a Node.js package that, given a subject, will generate somewhat random phrases and sentences and paragraphs on that subject. And the inspiration for this was my day job. I am creating this web application that needs to be tested with a lot of data. I want to demonstrate the web application running with a database with data in it. And that's a common thing to happen. People want to show a system with some data in the system. And it's very hard to come up with real data. You have to spend a lot of time writing fake data if you want to do that. In some scales, it's just not feasible to do it. Alternatively, some people try to sanitize some real-world data from another system and migrate it into the system that you're developing, but that is complicated and in some cases troublesome if you cannot really anonymize the data to begin with. And in some cases, you can find like a corpus of, like, for instance, if you're doing emails, if you're doing an application that has to do with emails, you can find a corpus of emails and work with that. But that's not my case. And then in some cases, what people turn to in that situation is something like Faker.js. And Faker.js is great in that it can generate a lot of fake data. The problem is that it generates lorem ipsum, effectively. It generates phrases in Latin that have no meaning at all. And that's kind of okay if you are doing some design or whatever, but to show a system working, it's not ideal. So here's what I would like to do instead. I would like to generate sentences and phrases that are random, like these phrases are random, but they're not in Latin and they're not just really, really random. I want to use a Markov chain to generate sentences that kind of look like something that maybe someone would say on that topic. So that's the idea. I'm going to create this package called Conversationalist. And what this package is going to do is, given a topic, like randomness, that's a topic, it is going to spit out sentences that have to do with that are in the vicinity of that topic, that are related to that topic. And it's going to be random phrases, but it's not going to be like completely arbitrary. It's going to use a Markov chain to do that. And the idea that I have is, given a topic, I'm going to search Wikipedia for that topic and related articles on Wikipedia. So I'm going to like follow links from the main article or do a query and find the 5 top hits and then go to those documents, to those articles. And I'm going to use the text from the Wikipedia articles to train the Markov chain. And then I'm going to use the Markov chain to generate the sentences or paragraphs or books. If you need a whole book on a topic, you can generate one. It just will be a random book, so you're going to have a hard time publishing it, maybe, probably. But that's the way it goes. Okay, so that is the idea of the project, and it comes in many parts. So actually, let's just get started. Let's get something rolling here. So I will go to my code folder, create a conversationalist. Did I get this spelling right? I think I did. Oh, and I have leftovers from yesterday here. Some of the apps that are open, and even the contents of my desktop are stuff from the stream from yesterday. Okay, Conversationalist, I got it right. And I checked, and it's available at NPM as well, which is good. It's going to be a node package, so it's good that this name is available. All right, so let's make this folder and go in there and get something rolling. I think that I'm going to start with just the boilerplate stuff, because I know I will want to have a package, and this is not just an experiment. So I'm going to get the boilerplate going, and then we can think about the things we need to do. So the boilerplate, and by that I mean things like a license file and package JSON, that sort of thing. And then we can start the Wikipedia scraping. We need to scrape the articles to get their contents and possibly links, so we can crawl more articles, because I believe that one of the parameters for your for the API needs to be how much text do you want to use to train. If you use more text, your Markov chain will be richer and you'll get better results, but it will be slower. So I want you to give you that option of how much text you want to scrape from Wikipedia. And then we need to train the Markov chain. And I need to say that I'm no specialist in natural language processing or in machine learning, all those topics. A Markov chain is a pretty simple exercise. And I even found some packages in NPM that implement Markov chains, but it seems like none of them are like really polished. I mean, I'm not trying to throw any shade at the people who have NPM packages on Markov chains, but most of them don't even have typings for Typescript, and the ones that do, I tried them out and they didn't really work for me. Maybe I made some mistake, I wasn't following the documentation correctly, but they just didn't work well for me. So we are going to do this from scratch. We are going to implement the Markov chain from scratch and then generate. And I'm not even sure about the terminology. Again, I'm no specialist, so I don't know if you say that you're going to train a Markov chain or if there is some other terminology here, but that's what I'm going to go with. So generate random sentences or text, because it may be longer than a sentence. So I think that this is how this is going to pan out. We'll see. So let's start with the boilerplate. I do want to create a repository for this, and I do want to commit and push to a public GitHub repository. So there you go. Now you can go to github.com/liafax/conversationalist and you can follow along the code. Let's see, in terms of boilerplate, what I need to bring in. I think that maybe the best way to do this is to look at another project. So there are two ways to do this. I can do it from scratch, or I can look at another project that has more or less what I usually do. You know what? Let's do it from scratch. So I'm going to install Typescript and TS. Well, these are development dependencies. So I'm going to install Typescript. I want to write this in Typescript. I will install TS Node so I can run my Typescript as if it was Node from the command line. I don't need to compile it first. And I know that I will want to use Jest for testing and TS Jest to test Typescript code. Okay, that's good for now. Also, I need the whole structure of an npm package, so I guess I will do npm init as well. I'm going to change this to package hello so I can say npm init, which is going to give me a bunch of metadata that I need. So package name, conversationalist, version. Actually, let's say that this is version 0.0.0. Description. This is important because this is the kind of thing that helps you get search hits when people are searching for this. So I definitely want Lorem Ipsum in there. What else do I want? never run out of conversation. Better than lorem ipsum. Fake text about any topic. Yeah, I think it needs to go actually the other way around. So let's see. Create a new buffer. So fake text about any topic, better than lorem ipsum, never run out of conversation. I'll be right back. There we go. So fake text about any topic, better than lorem ipsum, never run out of conversation. Entry point. I think I'm going to have a folder where I compile my TypeScript to. So I will call this folder distribution/index.js, and test command, it will probably be like prettier. I will want to have prettier, and I will want to run prettier on the source directory. I know that I want, so I guess I will have to check one of my other projects. I know that I want this to work on Windows. So let me go to like Caixa, for instance. And I'm going to see the command line that I need. So, oh, I need to say check for this to work. And here I need to say end offline auto. That's necessary for Windows. And then I will run jest. There you go. In the Git repository, I don't want it to be HTTPS. So let me go to my and copy my, oh, actually no, this is not, this is public, this is for everyone, so it needs to be HTTPS. In fact, I think that I can just say that, and GitHub is a special case, and that works. So keywords, in terms of keywords, what do I want? Fake text, I want lorem ipsum, I want faker, just because Faker is a popular library for generating fake text. Markov chain, and testing. All right, so the author, it's me. I think this is the format that you need to use. No, it's the other way around. Conversationalist. License, I'm gonna go with MIT. That's usually what I do. Is this okay? Yeah, absolutely. So now we have a package JSON, and I'm going to copy my dev dependencies in there. Why do they give me this whole thing? That is just crazy. It probably looked into my Node modules folder. Okay, let's review this. Name, version, description, main, dev dependencies. I usually like my dependencies to go at the end. So we want a test script. The repository can be written like this. That's simpler. Oh, and it collapsed my keywords. Maybe keywords need to be a single word, I don't know. But I think that this should work. And then I believe I can just say it like this. Yeah, let's check what I have here against my usual thing. So name, version, description, main. It could be nice to have a binary as well, but we'll see. Maybe we won't have one. I don't know. Oh, we definitely need some types. And I'll call this distribution. And I guess I need my, I prefer my script to go after all the metadata. Types, repository, keywords, author, license, bugs, homepage, scripts, dependencies, and whatnot. I know I will need something like this for TS_JS to kick in, but I will go with a source folder. And then I know that I want some other things. So you know what? I think it's better if I just clone Cache. Do I already have Cache on this computer? It seems like I do, but I think it's outdated. So I'm going to say clone again. Oh, and this is actually a terrible repository to clone because it's huge. Oh, there we go, not that huge. And I'm going to open. I know I want to git ignore here for both node modules as well as distribution. I know that because of this 5K files changed. It's because of node modules. So let's add Cache. And I know I will want something along these lines to test, so I'm going to copy this over. And I don't think I will have examples, source, stubs, that's specific to Cache. I will have a source folder. I'm trying to be more explicit, and I probably will in the future rename this to source. Then I want to code a conduct. I think I don't need to change anything here because this is the email address I give people. I want a license, that's the MIT license. And then your package stuff, and then tsconfig. I guess I will copy this over and just change what I need to change. And I don't think I need this. So here we are. We can close Cache now. And I guess we can commit everything. Oh, I committed too much. That's all right. Oh, I want to undo this commit. Because I committed with 2 spaces. I want 1 space as my commit message. Okay. So I also want as a dev dependency prettier. It didn't show up here. Oh, I am in the wrong folder. That happens to me every time, and then I end up with package JSON and node modules where I don't want. So let me create a new terminal and npm install prettier for development. Here it is. Okay, so now let's talk about the production dependencies. I know that I will need to scrape data from Wikipedia, and I think that probably the best way to do that is to use got, so I can fetch stuff from Wikipedia, and JS_DOM, so I can look at the HTML and find the links for related article, for instance. So that's what I'm going to do. I'm going to use these two, and I don't think that they both have TypeScript bindings. I know that got has it, but I don't think that JS_DOM has it. I think I need to import from definitely typed. So this one has TypeScript, but this one I have to import. So I have to say, as a development dependency, types JS_DOM. And I prefer my dependencies to go here. Like like your regular JavaScript developer, I start a project by copying up and pasting a bunch of boilerplate and installing 5,000 different packages. I mean, not directly, but indirectly, I installed just a whole lot of things. There you go. That's the way we do it. So now I think we can take out this item from the list. We created the boilerplate. Now let's do the Wikipedia scraping. So we need to start thinking about the API that this is going to have. I think that I'm going to export a function, maybe even the default export. And this will take as argument, well, the first argument is going to be my topic or my subject. How do I say it on the README? About any topic. Well, topic or subject. What does Wikipedia use here? I guess it's article. They talk about articles. Yeah, I'll go with topic, which will be a string, and it's required. And I will also have some I'll also have an optional argument for options. And yeah, let's start doing something here. Let's go to Wikipedia, and I looked into this before I started the stream, if there was like a Wikipedia API I could use, and there is one. So maybe let's go ahead and use that. So Wikipedia API. Get article, something like that. Yeah, that seems more or less like the kind of thing we will want to have. So this is the entry point for the API, and the action is what you want to do. Query, and then prop revisions, review prop content, section 0 titles. Yeah, that's not exactly the API call I want to make. So using the revisions API, so there are 3 different flavors for this API. Using the revisions API, you get the text as written in the Wikipedia markup language called Wikitext. That's not exactly what I want. Then method 2, flavor number 2, is to get the content as HTML. Or it seems like you can also get Wikitext that way. And the third way is to get just the text. So Wikipedia does its best to get just the HTML out of the to get just the text out of the HTML. So I think that plain text or limited HTML extracts. I don't think I want this version because I will want to follow links. So I think I want the HTML version. So it will look something like this. So what do we have here on the URL? Well, it starts the same, but the action is parse, and I think the action is called parse because I'm using this Parse API. And then the page, oh, so query is probably like search. Yeah, I probably want to do that, but I'm going to start with a given page and try to extract the material from there. Then we will also need to search. So I guess I will do this. I'll put this on the README. Wikipedia scraping is search for the topic to find articles, and then get the articles, get related articles, via links. And then one of these options is going to be how much data do you want to use to train the Markov chain. And if you say that you want a lot of data, then I will scrape more of this related content. So yeah, action parse page, and this will be my topic. Not really, it will be, so I'll have here a constant that will be based on the topic, but it is the article. And it's pet door in this example. And then in here, I will call this, I guess it's called the page, so I'll call it the page. Then the property text, to retrieve HTML, set prop to text. So that's what I need to do. And format version. They don't really explain what's going on, but that is in every example, so I'm going to have that as well. So I guess this is going to be our URL that we are going to scrape. Now let's use got. So I think this will be an async function, because I will import got, and got will want to do things asynchronously, of course. And let's just log whatever we get as a result. And of course I put a sync up here because I needed to await down here. Now we can npx ts node index, and this will run the file. Oh, I just defined the function in the file, but I never actually do anything with the function. So this is going to run and not do anything, but that's okay, because we can create a test file, so index test ts, that will import from just globals. Is that how you say it? It's going to import, I guess, test and expect. So test whatever. And then I, of course, also need to import my package. So I'm going to import Conversationalist from dot. And then I can just call Conversationalist with whatever, really. This variable is being ignored. This is just a neat way for me to actually run the program. So I can now say npm t for test. It will run the test, which will run Conversationalist. Okay, so this spit out a lot of data, and then it means that, so it seems like this is returning JSON, like what is the best way for me to show this? Maybe by going to this. Oh, this is an HTML representation of the JSON format. You can specify the format. So we need to do that. I guess I will put it here. So format JSON, format version 2. And then so let's go to the docs for got, because I want to extract this as JSON now. JSON mode. Okay, you can pass an object as the body, but that's not what I want. I don't want to pass an object as the body. I want to parse the response. To receive a JSON body, you can either set the response type options to JSON or use promise.json. So I guess I can say here .json, this will be the JSON returned from the Wikipedia API. Okay, it spit out cannot log after tests are done. That's probably because I am not saying async await over here. But never mind that. This is some JSON. So I can say things like .parse maybe, .parse.text, and what's going on here? Its object type is unknown. So I would need to specify, because I'm using TypeScript, I would need to specify the type of what is returned, but I don't know exactly what the type will be. So just to make TypeScript happy, I will do it like that. Oh, I forgot to run prettier. Yes, okay. Okay. It seems like I have some some HTML here. Great. Let's see if this even makes sense. Let's see. We are going to the article for pet door. So how about we just go to the Wikipedia article for pet door? Wikipedia pet door. A pet door or pet flap. So let's search for pet flap. A pet door or pet flap, blah, blah, blah. So it seems like this is working. Excellent. So now let's parse this HTML that is coming in using JS-DOM. I can say import JS-DOM from JS-DOM, and then I can probably do this in a single line actually. No, not really. I'll call this the response, and I will call this the DOM. Or we will have an intermediate variable for the text. And then I'll have a DOM variable that will be JS DOM fragment. I think it makes sense to wrap this whole thing in a div. Like this. Now I have my DOM thing, and I can serialize, not serialize because I'm using a JS DOM fragment. The reason why I want this div here is so that I can say document window. Oh, come on. What is the type of this? Document fragment. So I can just query selector. Oh, all right. First element child, which is going to be my div, and then inner HTML. And there will be a first element child. Let's print this out. I'm now just going doing the round trip. I'm going to JS DOM and then back, just to make sure that I'm parsing everything correctly. And I think I am, because it still looks about the same. There you go. So now we can look at this not as inner HTML, but we can look at the text content. That will be important for training the Markov chain. And here we have just the text, which is kind of crazy because it has this edit stuff and whatever. That will throw things off in the Markov chain, but we can clean this up, I think. All right, so we can have the text content, and we know how to get, I guess I will have both here, the inner HTML. I'll have that as well. So we can get the article, and now we have to either do the search part or get related article via links. That's all interesting, but I'm going to leave this for later. Let's commit what we have and move on to the training of the Markov chain, which is more interesting. Maybe we can get a whole prototype working on the stream. That would be awesome. So now I have something to train with. And I'm thinking if maybe I should cache this, or anytime I test this, I go to the Wikipedia API again. You know what? I think I'm going to go to the Wikipedia API every time and not cache the text content, because I want to know if I'm going to run into any API limits. I haven't really read the docs on the Wikipedia API, so I don't know if there is a limit. I will test, and if I run into a limit on the API, then I will know that I will need to work around this somehow. So let's do it this way. Now next, let's do the Markov chain. So let's talk about Markov chains. What a Markov chain is you have this material that you're going to train over, and the intent of the Markov chain is to generate random text that uses the same vocabulary and sort of the same choices of phrases that the original text would. And the way it works is you break the text apart. So we are going to need to tokenize this. Maybe I should take notes as I explain this. So train the Markov chain. I need to tokenize the text. So I now have a huge string. I need to break it apart into words. And then I'm going to look at this thing called ngrams. N is a number that is an option given by the user. So the user is going to provide me how much, the size of this n. I'm going to look at words. For instance, let's say that I'm looking at this sentence. So the way that the Markov chain is going to be trained is, let's say that we have an n equals to 2. So the way this is going to work is we are going to say that search for maps to the. So if you ever see the words search for in the text, the thing that follows is the word the. And then for the is followed by topic. And the topic is followed by 2, and so on and so forth. So what I'm doing is mapping the 2 previous words to the next word. If n was 3, then we would have something like this for n equals 3. And so on and so forth. So you build this huge map. And in some cases, if your text is long enough, you have search for the topic, but you also have search for the material, search for the house, and so on. And you build this map. So you end up with, let's say that the text is a lot longer. You will end up with things like search for the, maybe for the topic, for the house, for the cat, search for the house again maybe, and so on and so forth. So you end up with a lot of these mappings. And then when you want to generate, so this is the training part. When you want to generate sentences, you pick a sentence to begin with, or some words to begin with, and you do that in the vocabulary of this training. And then you look at what is the next word. Well, search for the, I have only one option, so I'm going to say search for the. And then when I just have for the, so at this point, and this is a crucial point of a Markov chain, you forget about the first word here. You just look at the, in this case, we are looking at n equals 2. So we are looking at the 2 previous words, only the 2 previous words. We are not looking at everything else. So we forget about search and we just go to for the. When I see for the in my text, what are my options? These are my options. So I'm going to randomly pick one of these options, but I'm going to do this weighted. So house appears half of the times, and topic appears 1/4 of the times, and cat appears 1/4 of the time. So I'm going to do this randomly, but it's going to be a weighted randomness, so that house will be picked half of the time. So let's say that I throw the dice, and it's weighted dice, and out comes cat. So now I'll forget the for word. I'll just look at the cat, and then I'll say the cat. Somewhere in my training there will be a mapping of saying the cat sleeps, and the cat eats, and the cat sleeps again. So then I will throw the dice again, and I will say, okay, maybe this time the word that came out was eats, and so on. So I generate sentences that are not in the original material, but they sound like the original material because they use the same vocabulary, and they use some of the same word choices. So you don't end up with things that make sense, but they tend not to be complete gibberish. They tend to at least be grammatical. Usually a noun is followed by a verb, which is followed by a predicate, and so forth. So that's the essence of the Markov chain. So I need to tokenize, I need to build a map of engrams, and then I have an idea of how I want to do the random selection, which is weighted. I think I will need to compute the weights, and I'm sure that there are plenty of articles and videos and whatnot and books explaining how to build a Markov chain, but I just know the principle, and I'm going to go with that. I think it will be more fun this way, and then maybe in the future we can compare to the canonical implementations and see what I got right and what I got wrong. I just know the basic principle. So compute the weights. This is, and after this I think that the training is over. So generate random text, we can get to that later. So we already have an article and we have some text, so let's work on these steps. To tokenize. So what are we going to do in terms of tokenization? Well, first of all, I think it's helpful to have a variable to represent. I'm going to call this the corpus, and it's going to be our text content. Then what am I going to do with the corpus? I am going to tokenize it, so I'll say that I'll have a list of tokens, and I'm going to start with something super simple for the tokens. I'm just going to say that the corpus is split on, well, the corpus, I need it. What do I need? Why do I have a question mark? Why can the text content be null? It will not be null. So I will split on anything that is not a word. If I have a sequence of multiple things that are not a word, I'm going to split, and that's going to be my list of tokens. Let's console log this. See what comes out. Okay, so it seems like I have a bunch of words. A pet door, or pet flap also refer to in more specific terms such as blah blah blah. I think this makes sense. All right, so we are gonna go with that. Now I have my list of tokens. Well, I will start to build my list, my mapping. My mapping goes from tokens to tokens. And what do I call this mapping? I'm gonna call this the model. I'm just pulling terms from machine learning that I have heard once. So this is going to be my model. My model is going to be this mapping from a list of tokens, which is just a list of strings, into So the list of strings is going to be, so let me do an example here. So I'm going to set, for instance, a dog maps to exiting. So my set will be from a dog maps to exiting. There we go. So this is the kind of thing that I want to do. So it maps a list of tokens or a list of strings into a string. Not really, because a dog may appear again in the text. So I want to map this to objects that have a token, which is a string, and a count, which is a number. Let's see if I like this data structure. Then it would be like token and count equals 1. No, actually what I think is better in this situation is to have a map over here. So this will be a map of tokens mapping to their counts. So then I can just, when I see a dog mapping to exiting, I just increment the counter. But you know what doesn't make me happy about this? I don't think that maps serialize very well. Let's try this real quick on the command line. So if I have a new map that I call m and I set banana maps to the number 2, when I JSON stringify my map, I end up with empty. So instead of using maps, I'm going to use actual JavaScript objects. And this way I can serialize this. Why do I care about this? Well, because I don't want to rebuild the model every time. We are doing this in development, but I want you to be able to save this model somewhere and reload it. So you will train the model once and you put the model in your application source code. And then when you want to create some fake data for testing, you just pull in the model from the file system and you are good to go and generate some sentences. You don't have to crawl Wikipedia all over again. So the crawling will just happen once. Maybe we'll even have a command line tool for the crawling. Maybe. Let's have this idea here. Command line tool for caching, for producing a cached model. So that's what it is. It's a cache of the model. So let's do a quick search for... So I'm hesitant about using just an object because then I will not be able to pull tricks like this, where I have string array as my key. But I can just join, right? I can just join the words so they look like this. So it isn't a string array, it's just a string. Yeah, and then I can use an object. That's better. So my model is going to be an object that maps any token, which is a string, into an object of another token, which is a string that maps to a number. There is a fancy term for this, I think. What I'm building is a multi-map. And this is not even how I want to represent the model. As I said, I was kind of thinking about how I want to do this before I started this stream. And I think that I will need to compute the weights. So after I compute the weights, I will have my model. But I don't think that this is my model, actually. This is just the ngrams, or the ngrams counts. Let's see how people usually define ngram, just to see if I am making things up or if I am actually using the terminology from the field. Ngram is a continuous sequence of n terms given from a sample of text or speech. So in our example before, where n was equal to 2, that was a bigram, and if n is equal to 3, that's a trigram. How do I calculate? How do I say that it's a size? So an n-gram size is going to be our n effectively, and it is going to be a number, and by default is going to be 2. Oh, I don't say it like that, I say it like this. And it is optional. So now I need to traverse my tokens and build my engrams. Yeah, I'm going to traverse my tokens by just taking the index, I guess, or token index, and I want this to start. So I want a range. I guess I will not have a for off. I think I will just have a regular for loop. So my index, my token index, is going to start at my n-gram size. So if my n-gram size is equal to 2, I will start at element 2 in the tokens list, which is the third element. Then I will token index plus plus at the end, but in the middle I want to continue if my token index is less than my token's length. So if I have 3 tokens, the last one is token number 2. Do I want to run in that situation? I guess I do. If I have just 3 tokens, let's say the tokens, in fact, that may be a good exercise. So let's comment out this whole section as including this part. So this is me building the tokens by scraping Wikipedia, but I can also just say that my tokens for testing real quick is like a dog exiting. And now I have enough to do one. I'll call this just ngrams. I have enough to do one of these guys because n is equal to 2. So I should have a mapping of a dog maps to exiting count equals 1. So let's say that token index is going to be this guy. And I guess I'm going to call this the current token index. And I'm looking at this guy, which is number 2. So the indices of this array is 0, 1, and 2. And my current token index is with an n-gram size of 2 will be this guy, which is my current token. Awesome. And I want, so the length of this array is 3. There are 3 elements. And I don't want to run when my current token index is equal to 3 because that would be an element that is not in the array. So there you go. This is the correct for loop to write. And then in here, I will want to say that my ngrams at how many of these previous words I need. So I'm going to look at my tokens and slice at my current token index minus my ngrams size. So in my case, my current token is 2, my ngram size is also 2, so I will end up at 0. I'll slice from 0 up to, but not including, the current token index. That will slice the tokens array. That the type error is actually correct. So I will slice the token array to just get a dog out of the tokens array, and then I will join with a space. All right, so that is a space dog. That is equal to, well, first of all, I need to initialize this to an object, because by default it will be empty. So I will initialize this to an object like this. And I guess I will need to extract this. This is going to be like what, my key, for the lack of a better value, a better name. And then I can say add my tokens at current token index. So I initialize this object to be empty, and then I'm saying that at that position, that is my tokens at current token index, so that's my exiting, I am going to say that that is equal to whatever was there plus 1. But to begin with, nothing will be there. So I can say or 0. So if nothing is there, then I get 0. Then 0 plus 1 is 1. Otherwise, I will get whatever was there plus 1. And then at the end, I can console log of my ngrams. What I expect to see is an object that has a key that reads a dog that maps to an object that reads exiting that maps to 1. And that's exactly what I get out. So these are my ngrams. I got that much going for me. But if I just have the counts, it's enough for me to do the random picking of weighted words that I mentioned before. That's enough. But it's inconvenient, because how do I do this weighting? Well, I need to know what are the... Okay, let me give you a specific example. So I had my example here. So let's say that a dog maps to exiting with a weight of 1 and maps to slips with a weight of 2. I want to pick this 2/3 of the time, and I want to pick this 1/3 of the time. So to do that, I want to pick this is I want to pick this 2/3 of the time, and I want to pick this 1/3 of the time. To do this, I need to know this number, and this number is the sum of all these weights or these occurrence counts. I don't want to have to do this, to compute this 3 every time. So my model is going to do this calculation for me. It's going to do that calculation for me. And then I'm going to store something like 1/3 and 2/3. I think that will be less computationally intensive, and that's why I'm separating this idea of engrams from my idea of a model. The model will have the weights already calculated for me. And then my idea later is that I'm going to do something like math random, and math random will return me a number between 0 and 1, and I can do it. I can do it like this. So 1/3, 1/3. So if my random number, for instance, is 1/3 without a fraction, 1/3 is 0.333, and 2/3 is actually, maybe I don't want to have 2/3 here. Maybe what I want is the addition up to this point. So this will be 1 actually. And then if my random number is like 0.5, or actually 0.1, then I pick exiting. If my random number is something like 0.5, then I pick this one. So I can just generate a random number, traverse this object, and whenever I find that my random number is less than this thing that I'm not even gonna call weights or probabilities anymore, it's just the cutoff. It's if my random number is less than the cutoff, that's my option. Less than or equal to, just to make sure. Yeah, so I'll call this the cutoffs. I'll also have the weights. I think that will become important. So this is 1/3, this is 2/3, and I'll also need some notion of total weight, and that is just 3. That is the addition of all the counts. Yeah, I think I like this. So I have a total weight, some weights, some cutoffs, then my random number, and a strategy. So I just look at my strategy for picking the weighted thing is going to be math random less than or equal to the cutoff. So let's build a model from the engrams. My model, what's the type of my model? Well, it maps, it's pretty much the same thing, I suppose. It matches my, it's not even a token at this point, it's tokens. Which is a string. Maps to an object that is just a token, which is a string, mapping to a number, which is a probability, no, a cutoff. That's what it is, a cutoff. So, how do I build this object from my engrams? I need to traverse the engrams, and that's what I'm gonna do now. I don't know what I'm gonna put here, but I will do an object entries of my engrams. This will give me my tokens and my what do we even call this? Next token? Whatever. Next tokens, because we have more of them like this. So now we need to compute our total weight. Total weight. It's not even a weight. I think it's just a total count. Yeah, total count or total count. I will call it total count for now. So for that, I will do object. So our next tokens here are this portion. Let me put some names here. So this is our tokens variable, and this is our next tokens. So we can just say object.keys values, actually values of next tokens, and then we can add them together. Is there something to add everything together? Reduce. JavaScript add array of numbers. Reduce array of numbers addition. That is very low level. Yeah, it seems like people reduce. That is just crazy. You generate code and evaluate it. That's crazy. Don't do that. Yeah, it seems like that's what you do. So I do want the version with the default value. Okay, so I just give the default value as a second argument. And then I give a function that will be previous value and current value. That's great. So total count and count. And all I have to say is total count plus count. Let's console log this total count situation. We should see the number 1 coming out, because the total count in our simple a dog exiting example is 1. The total count is 1. We see 1 coming out. Kind of a lame test, but I think it's working. And then we want to transform this map, this object, into something that looks like this. So we'll have a weights kind of thing going on. Yeah, I think that's what we're gonna have. So we have a weights thing going on. We'll do object entries of next tokens. Well, we can map over that, and here we'll have a token and a token count, and we can map to an object that has as a key how do I make this? I guess I write it like this, and then I say token count divided by total count. Is that how you do a is that how you do an object with a key that is a variable? I think that's how you do it. Let's console log our weights. And in this case, I expect the weight to be 1 actually, because we are not running the example that comes from here is not the same as this one. So it is what it is. Well, I guess we can do the same trick as before. We already know how to do the ngrams, so we can take the ngrams out of the equation and just say that our ngrams, for the sake of testing, is this. And then the weights should be exactly this. Oh, I have a syntax error. Where is the syntax error? Ooh, spooky. I have a very weird syntax error going on. Still a syntax error. Oh. I think that this comment should go here, and then I remove one of these brackets, and then it's correct. Okay, let's try this again. All right, so we got our weights. Now, let's have a current cut off situation going on. It will start at 0, and then we'll do something similar to this, in that we'll be mapping over the, this time over the weights, and this will be a token, and this will be a weight, and this will be our cut offs. So we take the token, and what we do in this block is we say that our current cut off plus equals this weight, and we put the current cutoff there. I have some type error going on here. Ooh, spooky. So our weights is a list of objects. Oh yeah, so I also need to say object from entries. Oh, and then I don't want to return an object. What I want is to return an array in which the first element is the token and the second element is that. And then my delimiters are all crazy, but I think if I just put enough parentheses, that should go through. All right. So now weights is just an object of keys mapping to numbers, or of tokens mapping to numbers. Okay, I will need to do a similar trick over there. So I'll copy this object from entries, and then over here I don't want this to be an object. I want to return this. Forgot to say that. There we go. My cutoffs has the same type. It's a token mapping to a cutoff, and then I guess I will be able to do this in a single step, because I can say that my model is just a mapping of that. So Let's do a similar trick over here. We will say something similar to this, and I won't need a type annotation. It may be helpful to have one, but I won't need it, so I'm removing it for now. And then I will not go. I will loop through the ngrams with tokens and next tokens. And my block will be essentially this block. And what I want to return what went wrong here? Did I copy and paste from the same place? I think I did. There we go. So I can remove this part. And then I need to return something out of this block. And what I return is just my tokens mapping to my cut-offs. Let's console log our model. Yeah, we got this. So our cutoffs is a third and 1. Crazy stuff. I want to commit this. I'm happy with what I have in that it works. Kind of works. I think it works. And now that I did this in 2 steps with the weights and everything, I realized that I don't need to do it in 2 steps. I can do it in one single step. So I do a total count, and then instead of adding the weight, I add this, and instead of looping over weights, I loop over next tokens, and then instead of weight, I will have the token count, and I can remove this part. There you go. So here I am mapping over my ngrams. I'm taking the total count, and then I have a current cutoff, and then I have my cutoffs, just mapping over the next tokens, and I calculate the weight. As I'll call this the weight for readability. Then the current cutoff is plus the weight, and then return, and we essentially got rid of this middleman, and we are going straight to the cutoffs. The output's still the same. Perfect. I think we nailed this. I think we have a model. Let's commit. Then of course you want to cache this model by saving it to a file, and that's very easy to do. You can just JSON stringify it. So let's go through the whole process now. There you go. Just cleaning up the other test things that I had going on. So here we have a section that does the scraping, a section that does tokenization. So let's put comments here. Scraping, tokenization, engrams count, and build model. And I want to see a model running with the real pet door training thing. Oh, it takes a little while. That's okay, but it seems like it worked. In most of my model, I only have like one thing going on, which is unfortunate. but it's not in the whole model. Oh, that looks nice. Not really. It's not great. But maybe it's because it's like the references and everything. Isaac Newton is followed by a bunch of different things. That's alright. Okay. Yeah, I don't really need this console log going on. So maybe what we can do next is to try to use our model to build a sentence. And I also need you, the user, to give me what is the sentence size that you're interested in. So for now, I'll just hard code this. So how do we even start? We could have looked at words that start sentences. But in fact, in our tokenization, we got rid of that information. So what I'm going to do instead is just pick a random word, start from there, and select 5 words if I can, and stop. So I'll have a start token. It needs to be a pair of tokens. So I will go to my tokens and slice over start token index, which can be a random value that goes up to my token's length, and I take the floor of that. And then I take a slice from my index plus 2, or actually ngrams size. That will give me 2 elements. Or actually, I think this is like the start tokens. Or better yet, this is going to be my start token. I take it back, because I can immediately join that with a space. Then we can say for, let's say that we have a sentence that starts empty. It's going to be an array of strings. I don't know why I'm giving this a type if this is going to be thrown away anyway. And at the end, I'm going to console log my sentence. Now, my sentence is going to start with my start token. And I am going to for const underscore of new array of like the number, let's say that we want a sentence of 6 words. And this is just a neat trick for me to run this loop 6 times. So now I can say something like next. I'll have to have a random number. So I'll have my random number. I'll call this number X. I don't know what to call it. Then I need to find my next token. So my next token is going to be well, I need to find my current token. What is my current tokens? So I'll call this the current tokens, and it's going to be my sentence sliced at minus ngrams size, joined with a space. Yes, that's what I meant. So my current tokens, can I do this slicing with a negative number in JavaScript? I think I can. So if I have something like 1, 2, 3 and slice with -1, I get just the last one or just the last 2. Then I join in with a space. Then I check. what do I call? So I have a model. Oh, maybe I should have had that type annotation, because now I don't remember the type of this anymore. So it maps tokens, which is a string, to an object that has a next token, which is a string that maps to a number, which is a cutoff. So now I am going to look at my model with my current tokens. That will return to me my next tokens, and if next tokens is undefined, I'm going to break out of this loop. I cannot do a sentence that is that long. That's all right. Now I take my random number and I try to find my next token based on this random number. For that, I go over my next tokens and I try to find, I will have a next token and a cutoff, and I try to find the token such that I had the formula for this, but I guess it's x less than or equal to my cut off. So if my x is, like in our example it was 0.1 and our cutoff was 0.3, we wanted to pick that. So our cutoff is going to be 0.3 and x is going to be 0.1, so less than or equal is appropriate. And it needs to be less than or equal because my x may be like exactly the number 1, and in that case the cutoff needs to pick a next token. And I think I have the same situation going on about the less than stuff somewhere else. I guess over here. If my random number is exactly 1, can it be exactly 1? It returns a pseudo number between 0 and 1, mdn math random. Inclusive of 0 but not 1, so that's alright. So here we are fine, but here we would not be. Okay, so now we have our next token. What do I do with the next token? I take my sentence and I push the next token. And it may be undefined. Well, it will not be, I know that. But my next token is an object, so I need to take the first element. Alright, that's the moment of truth. Let's run the tests and see if we came up with a random sentence on the topic of pet doors using a Markov chain. Alright, we got something. 1957 and cat. It's not a long sentence, but it is a sentence. And does it appear on the Wikipedia article for this? I think it appears literally on the Wikipedia article for this. And cat door. And for whatever reason, it did not find and cat to get door. Do I have something weird going on here? Do I have an obvious mistake? Well, my sentence is an array of strings, so I want to join that with a space. And I also want to put a period at the end. Well, I guess I'll call this a sentence parts, sentence tokens, and then my sentence is going to be my sentence tokens joined with a space and a dot at the end, so it looks more like a sentence. Let's run this again. It will give me a different random sentence. E.H. Sears. Again, only 3 words. And here we had only 3 words as well. So I think I'm making some kind of mistake. Let me commit what I have because it partially works, but I already know something that is weird here. So my start token, I already combined the thing with the join, but here I had a join as well, so that is incorrect. What I need is just to slice this, and this will be my sentence tokens to begin with. Let's see if this changes anything. There you go. A thumb operated switch or a wire lattice. Does this sentence occur literally in the text? No, it does not. I generated a random sentence. A thumb operated. Thumb. Oh, okay, there was a dash. A thumb operated switch. A thumb operated switch or wire lattice. A thumb operated switch and wire lattice. We did it. We did it. We generated a sentence that is not in the original text, and it's so good that I thought it was in the original text, but it wasn't. Awesome. Okay, so let's wrap this up. I am going to push this as it is. Doesn't really matter. GitHub is going to try to run some tests on this, and it's going to like be, no, not really, but whatever. But that's it for today. Let's see if there is something else here in the README that we need to remove, because we did a lot. We tokenized, we built a map of engrams, we computed the weights, we generated random text. Yeah, of course there's a lot to refine, but we have something. That makes me happy. So yeah, we scraped Wikipedia, we built a model using Markov chains, and we generated an honest to goodness random sentence. I want to see this again. I want to see another random sentence coming out of this. Door running through a wall several types of. That's not a good sentence, but it was running through a wall and several types of. That's definitely not a sentence in the original article because it's not a good sentence. Yeah, several types of. And let's look for just several paths. So how did it go from a wall to several? Oh, because this image, this is great. So this image is here on the left, on the right. So it is actually a floating window. So this text in the HTML appears before this paragraph. So literally in the text, it does occur: door running through a wall, door running through a wall, several types of. So we generated a sentence in the text. And there is still a lot that we need to do to make this more polished. Like we want to find we want to find the beginning of sentences so that we start sentences in a way that makes sense. And maybe we want to include punctuation in our tokens so that the sentences kind of end in a way that makes sense as well. And of course, we need to get. So yeah, I'm going to take notes here. So find beginnings of sentences. Currently, the way we are doing this is just we are picking any beginning randomly, but it would be nice to find the correct beginning of a sentence and take punctuation into account to end sentences in a way that makes more sense. And this is find the beginning of sentences to start sentences in a way that makes more sense. All right. And we need to improve the scraping so we get more data so that our corpus is bigger and our model is more, it's richer. And we need to cache this so we don't go to Wikipedia every time we run the tests. So yeah, still a lot to do, of course. And then we need to publish this to NPM. We need to write some good docs for it. But I'm very happy that we were able to kind of build a working prototype in a single stream. We did a whole scraping of Wikipedia, building a model and producing a sentence using a Markov chain, that a sentence that was not in the original text, which I find like, whoa, crazy, it worked. Awesome. So thank you all for being here and for supporting me on PayPal and Patreon, for subscribing to the channel. And I see you all tomorrow. And I don't know if I'm going to continue working on this or if I'm going to go back to Notestrator. I think I'm going to go back to Notestrator. Yeah, so I see you again tomorrow to work on my other app. It's also JavaScript. It's written in Electron, allows you to draw on top of your computer screen. We're going to continue working on that tomorrow. Bye.